Welcome to my first milestone project, which is all about quartz in my home community of Wisconsin and generally the Great Lakes region. So specifically, I'm going to be talking about St. Peter sandstone, which is a large quartz deposit in my region and also several other states near me, where there's lots of quartz that is very uniform and unusually high, like pure quartz content. And so, first of all, quartz characteristics and uses. The quartz belongs to the silicate mineral group. It has a chemical formula of SiO2, which is silicon dioxide, and it has a framework atomic structure. Some defining characteristics of quartz are that it has a hardness of 7 on the Mohs scale, it has a vitreous or glassy luster, it fractures conchoidally, meaning that there are no clear fracture planes, and this is this is due to the framework atomic structure. Quartz is felsic, and quartz does not help identify, or color does not help identify quartz because other metals like uh, iron, potassium, sodium, magnesium, calcium, and aluminum bond with silica, with silicon, and this changes the chemical composition and the color, which makes it easily or it makes it look similar to other minerals. And so over here is an example of quartz that has different colors in it. And so some general uses for quartz are including it in glass, using quartz for decorative properties, so like countertops, or like some people decorate their homes with crystals. Um, and also fracking. And so fracking is the main economic value to my community. Um, the quartz from St. Peter sandstone is also used for making glass, but primarily it's used for fracking because, as I said, the fracking sands, which are made of quartz, are very uniform, they're very round, and very pure. And so St. Peter sandstone quartz is often mined for fracking. So geological setting, where quartz is formed. So quartz is very common. It can be found on all 7 continents because it's made up of silicon and oxygen, the two most prevalent elements in Earth's continental crust. There is an abundance of it all around the world. It can be formed from felsic lava flows underneath the Earth's surface. And per Bowen's reaction series, quartz is one of the last minerals to crystallize and first to melt. So it oftentimes acts as a matrix in igneous rocks. So this is an example of this. I draw out a diagram. So if this first picture is magma that is slowly cooling, first the ultramafic crystals will cool down, then more mafic crystals, intermediate, and finally felsic minerals. And quartz is the last to crystallize in this context because of the Bowen's reaction series, but also because silicon and oxygen are incredibly abundant in the Earth's crust, and it ends up filling up the rest of the magma chamber or wherever this magma is cooling. So the tectonic setting of quartz. So the Great Lakes region is located in the middle of the North American tectonic plate. Around 2.5 to 3 billion years ago, the area was part of the Precambrian Shield and Canadian Shield, where many of today's minerals were formed by Precambrian ancient volcanoes. About 1.1 billion years ago, the Great Lakes region was part of the mid-continent rift system that started to break apart this continent, but it stopped after 15 to 22 million years, but it created the Lake Superior Basin. And so as for St. Peter sandstone, the quartz has Precambrian origins, and it was built through sedimentary processes. So the ultimate source was a plutonic granite or plutonic terrain that was granitic. And the terrain is a fragmented block of the Earth's crust, but the immediate source was a sedimentary terrain. Sand from St. Peter's sandstone comes from Cambrian sandstone that was eroded for millions of years, and this quartz is very durable, or all quartz is very durable, so it was able to withstand weathering and multiple sedimentary cycles throughout this period of erosion for millions of years. So the modern tectonic setting of my home community is that it is currently in an isostatic rebound, which is really interesting. I didn't know about this. Basically, it means that the land is rising, parts of the land are rising because um, they've been so used to having heavy glaciers on top of them for so long, and so now that the glaciers are gone, the land is moving up without the continual pressure that the glaciers exerted on the land. And so I kind of think about this as similar to Newton's third law of motion, that every action has an equal opposite reaction. So it's like the force is kind of coming back now. Earthquakes in this region are very rare. Um, they happen maybe once every few years, if not decades. And in Wisconsin, usually they are just felt from neighboring states, which are also very rare. More common are cryogenic earthquakes, which we call ice quakes. They are basically the result of the rapid changing of temperatures of frozen and melting grounds. This often happens with our lakes that we have in Madison, but they're not very studied because they occur very randomly and in very like select areas. And these earthquakes have no tectonic significance. The end. Here's my sources, and also did not use AI to create this presentation. One final note. As for which parts of this project were new information for me, I would say that most of it, if not all, was new to me. I had always known that we had a lot of quartz in Wisconsin. Growing up, I would always, find pretty rocks and ask my mom, "Oh, what kind of rock is this?" And 9 times out of 10, it would be quartz. But I didn't know about the St. Peter sandstone. I didn't know about the use of quartz sand for fracking. I didn't know that it can be used for glass. So really, I was pretty unaware of quartz's context. Most of what I had learned before completing this assignment was from class, and so it was interesting to do some outside research and learn about its significance for my home community. Thanks. Bye bye.